Howdy folks! Excuse my lab bench here. I have a whole bunch of samples. I was out on a field trip with a local gem and mineral club, and we went out to a closed, old, abandoned lead mine. So I have a bunch of samples, so I'm just kind of sorting them out to see what I want to keep and how I want to organize them. But anyways, one sample I found has some brassy material in some quartz mostly, and one gentleman there told me it looks like chalcopyrite, and another one told me that it looks more like just plain pyrite because there weren't any blue edges around it. Now pyrite is just a plain iron sulfide, and the chalcopyrite is a iron and copper sulfide. So the presence of copper should be pretty easy to determine chemically. So I think I'll give that a try. And what I'm thinking of doing is dissolving in an acid, and then I can do a quick flame test and see if I see any of the flame colors from copper, and also once it's dissolved in nitric acid, you can precipitate out the iron with ammonium hydroxide, and the copper nitrate should still be in solution, and that should definitely have a blue color to it if there's copper there. So we'll give that a try. Let me show you the samples before we get started. I also have a small piece here which I'm thinking of using as a sacrificial piece to dissolve in acid. But no matter what it is, they're kind of nice pieces. Basically, these two were together, or they were all together somehow. But here's the biggest one. It has some on the surface and some on the outside. It looks like there's a vein going through the quartz right along here, and a nice surface there, and the vein continues across. Here's the adjoining piece. Once again, the copper, or the mineral is going through the vein here and across. It's got some different kind of colors. It's more orangish there. I'm sure it's tarnished, and if you look at it under magnification, you'll see some blues. I'll try to take some still photographs of through a microscope and share those with you too. But you can see some kind of blue iridescence and kind of some orange sort of colors. But hopefully that's coming across on the camera. And here's a small piece that is broken off, so that'll be handy. I can fit that in a test tube. Okay, looks like the original sample is 1.7 grams on the nose. The one analytical book that I'm following is I think it's called the Identification and Qualitative Chemical Analysis of Minerals by Orsino Smith. And I think his sample size he recommends to start with is 1/10 of a gram. So anyways, let me grab a test tube. So we have that piece in there. Grab our nitric acid and a pipette. Alright, so that's about 2 mils of acid. It's definitely submerged in there. And maybe I'll heat that a little bit too, just to expedite things. And we'll just gently heat this just to accelerate the process. And it looks like some of the material is flaking off. Look like it's bubbling on the sample now. All right, I let it sit for a while and added a little bit more acid, and not much happened. So I went back to heating it, and when you heat it, you can definitely see the reaction speed up and bubbles coming off of the sulfide deposits on there, and you can see the orange gas, the nitrogen dioxide above there from the reaction. So I'm going to continue to heat it, and instead of the yellow color, it looks like we are getting kind of a greenish, so maybe there is a bit of copper in there. Let me bring the camera in. I don't want to take it out of the hood, but I don't know if you can see the bubbles right on the specimen as it's reacting. So anyways, I'm going to continue to heat this slowly and try to get as much dissolved as possible, and then we'll go do some further analysis with it. But looks like it's getting to be a little bit of a green color, so there might be some copper in there after all. All right, it's still bubbling away, and I don't know if you can see, we got some clouds of nitrogen dioxide coming off of the top of the tube, which is highly toxic. So you definitely don't want to breathe that, and definitely want to do this in a fume hood. Okay, I've been boiling this on and off for at least an hour. The solution kind of started to boil down and got pretty dark, and so I added another ml of acid and a little bit more water. But I think I'm going to give it, call it quits here, and I'll let it cool down, and I will fish out what's left so I know how much of the sample is dissolved, and go from there. And maybe I can do a quantitative analysis a little bit. I'm not real comfortable with the numbers, but just to try to get some idea of how much copper is there, because now it does look like there's copper with the green solution. So maybe I can precipitate out the iron, and then maybe precipitate out the copper back as a sulfide again, and get some weights of each of those precipitates, just to get a relative idea of how much of each one is there. Alright, I finished dissolving that sample, or at least part of that sample, in nitric acid, and it does come out kind of a greenish blue color here. I don't know if you can pick that up on the camera or not, but so maybe there's some copper in there. Just for comparison, this is a sample from magnetite that I was playing around with, definitely yellow, and this one is a sample of, it turned out to be pyrite. I wasn't sure what it was at the moment, but you know, as you can see, the one on the left here definitely has a bluish green tint to it. And here's what's left of the rock. There's definitely still a lot of material left on there. That's all the stuff that was left over. I did reweigh that, and I came up with just under 0.2 of a gram of material that dissolves. So that's about twice as much as what Orsino Smith recommends in his book. So that should work. Okay, I split the resulting solution in half, so I have some left over that I can do a flame test, or there's some other copper tests that I can do. But right now what I'm going to do is I'm going to precipitate out the iron by reducing the pH here, or I'm sorry, increasing the pH with ammonium hydroxide. Let me get some pH paper ready here. We know there's definitely iron in here, so we should see a whole bunch of brown precipitate, reddish brown precipitate coming out. Let's see how we do here. Okay, just make sure I got the right stuff. And precipitate is starting already. It's kind of greenish, a little bit. I'm going to stay inside the hood. I hope you can see. Oh yeah, see how the stuff, it sort of dissolves when you mix it in with the rest of the acid in the solution, but as soon as it gets neutral, it'll remain there. Okay, once again it formed and redissolved. Forms. And it looks like it's starting to redissolve again. Maybe not. It's kind of close. Let me dip in a little piece of pH paper and see what we have. Still a little bit acidic. Or close to neutral, I should say, maybe. Let's add another drop or two. Alright, definitely lots of orange-brown precipitate there. So we're going to run that through a centrifuge and separate out the iron from the copper, or from the solution, and then we can test the solution for copper, or try to precipitate that out, maybe with hydrogen sulfide, to get a insoluble copper sulfide, and we might be able to see how much precipitate of the copper is there, because the blue color isn't really all that real strong, so maybe there's just a trace of copper and obviously lots of iron. So alright, I ran or put the sample in a smaller centrifuge tube along with some water and another tube to balance out the centrifuge. We'll close that up and turn it on, and we'll go ahead and we'll let that spin for a couple minutes here and separate that out. Okay, we're going to turn that off after centrifuging for maybe a minute or two, a few thousand RPM. Take that out, and here's our water, and here's our sample. Wow, definitely see a color there. That's alright. Well, I was kind of skeptical that this was chalcopyrite, and it looked like there wasn't all that much copper in there, but by the deepness of the color of this solution, there might be more than I think. So I'll go ahead and pour that off, and we'll have an idea of how much iron we have in there, and then we'll try to precipitate out the copper and see how much copper we have there. Okay, this is where we stand so far. We had our quartz with our either pyrite or chalcopyrite deposit on it, and we dissolved that, or at least a portion of it, in nitric acid, and we came up with this light blue solution. We took the pH up with ammonium hydroxide, and we got this brilliant blue, I think it's a tetraamine of copper, which remains soluble, and the iron precipitated out as iron hydroxide. And here's the iron hydroxide. It's just about dry on a watch glass on a warming plate, so I can get a weight on that just out of curiosity. Even though this didn't start to be a quantitative analysis, we'll get some idea. And I actually split this copper amine complex here in case I screw something up, but what I'm going to do now is neutralize it with hydrochloric acid, and then add excess hydrochloric acid to it, because when we make a copper sulfide, it will precipitate out of a hydrochloric acid solution. So basically what I'm going to do is I'm going to bring this neutral, and then I'm going to add a couple drops of, or I'm going to add, I think I'm going to need about 5 drops excess of concentrated hydrochloric to bring the pH down. And then we'll use this gizmo here. This is my crude hydrogen sulfide generator. It's just an old-time paraffin, sulfur, carbon, and maybe there's some other stuff in there, generator that you heat, and it'll give off hydrogen sulfide. But we'll bubble that through the solution and try to precipitate out the copper. And we'll go ahead and bring the pH back towards neutral first. Alright, that's pretty darn neutral. So we're going to add some excess acid here, 5 drops. This is the procedure according to Orsino Smith. I'm also looking at a book. I have another qualitative chemistry book, and I forget who the author is on that, but the procedures are pretty similar. Well, actually it clears up. So what we want to do is bring it to a boil, actually. And at that point we can, I guess I'll get the old alcohol lamp going. Okay, I have the hydrogen sulfide generator going. It's just starting to produce some bubbles down here. You have to kind of be careful not to heat it too fast or you get some sulfur subliming over. Alright, we might just be getting some hydrogen sulfide through. I'm doing a good job of keeping the sulfur out. The tube's nice and clear, but down here in the test tube, we're definitely have a precipitate going on here, a black precipitate, which I think is the color of copper sulfide. So we're going to continue bubbling here and make sure we get everything precipitated out. Okay, I bubbled hydrogen sulfide through here for a couple minutes, and looks like I have a lot of precipitate. I don't know if I need to do more or not, but centrifuge this and separate it out and continue bubbling water through the liquid to see if more needs to come out. In fact, it's starting to settle already. It's starting to get a little bit clearer near the top, if you can see that. But let me go ahead and clean this up, and we'll try it again to see if there's any more in solution that needs to come out. Okay, I got the precipitate and solution out into two centrifuge tubes. Actually, the tube that I was using is actually too tall to fit into the centrifuge. So anyways, let's go ahead and give this a whirl, pun intended, and separate out the liquid and see if we can precipitate any more material out of that. Okay, here we are out of the centrifuge. Got a good bit, at least in the one tube. We'll decant the liquid off, and okay, this is after the second go around with the hydrogen sulfide, and I think there's still quite a bit of precipitate, so I'm going to pour that right on top of the other precipitate and centrifuge that out. Okay, I washed all the precipitate from the copper sulfide out of the test tubes into this watch glass, and I'm going to put it on the little warmer here and let that dry off. Maybe I'll pour a little bit of the water off too, and we'll weigh it up and see how much we have. Okay, we have both of the precipitates dried out. This one was the iron hydroxide, and it's just kind of clear through there. And this one is the copper sulfide that we separated. Looks like there's quite a bit more iron. Don't forget we split the amount of copper solution in half before we dried this out and separated it. So there should be, twice as much iron. But we'll get them all weighed up and do some calculations and see what kind of ratio we have of copper to iron. Hey! So far this has worked out pretty well, but for the sake of completeness I thought we would go ahead and just confirm the iron and the copper. The black precipitate from the copper sulfide is pretty indicative of copper, along with, this definitely is. This is the tetramine copper is, that the color is very distinctive, so we're pretty sure there's copper there, or almost, pretty positive, but we'll do the official confirmation test, and we'll test this for iron, that this has both the copper and the iron in it. But come on over here, hang on while I move the camera, and we'll look down on the spot plate. I don't use spot plates very often, or haven't before. So the first thing we'll do is we'll take our acid solution from our rock sample that has both the iron and the copper in it, and I'll put some in one of these cavities, and I will add, this is copper ferrocyanide, and if there's a ferric copper in there, or I'm sorry, if there's ferric iron in there, it will turn a deep blue, a Prussian blue color. So let's go ahead and add a drop and see what happens. Wow, definitely a lot of iron in there. So, you know, we guessed that either being pyrite or chalcopyrite. The next thing we'll do is we'll look for the copper, and for that we'll look at this solution that we already precipitated the iron out, so it should be just no iron and just copper. So I'll take a little bit of that, and you're supposed to adjust the pH with acetic acid, and we're supposed to take it back down towards being acidic after we added the ammonium hydroxide. It should turn a light blue color again. One drop is enough. See, it turns back to kind of that original color that we had from our rock sample, but there shouldn't be any iron in there, and but there should be the copper. So we're going to add the potassium ferrocyanide again, and if there's copper present, it's going to become copper ferrocyanide, which will be shown by a deep red precipitate. So let's give that a whirl. Wow, all right, so we definitely have lots of copper in there, so that worked out well. All right, well, that's about all I can do to prove there's both iron and copper in there. I might do a flame test too, just because I don't have a lot of experience with that either, and it might be interesting for me just for the experience of doing it and seeing what I come up with. So pretty cool. I'll come up with some of the calculations that we have from some of the weights, and we'll go over that, and then call it quits. I think I beat the heck out of the sample enough, so hold on. Okay, I know we beat the sample to death already, but the last thing I'm going to try is a flame test on the copper solution that we've got from the sample. This is a nichrome wire. I'm going to dip it into hydrochloric acid, which is in this tube, and put it into the flame, and it should be colorless. If it's not, I'll do it a couple times until I clean the wire off, and then I'll go ahead and add it to the copper solution. In fact, see if there's that color for copper, which is that the green. No idea if this is going to come out on the camera, so I'm going to bring the camera up. I'm going to shut off some lights here. Hopefully not too many, so I can still see what's going on here. I don't know if you see anything at all yet, but we'll get the torch going. I'll try not to burn myself. So I'm going to just put the loop into acid here and stick it into the flame. Well, I'm definitely getting some orange color. That's not good. Alright. Let's squizzle that around a bit. Okay, initially there's not too much color, but it definitely turns up to a kind of an orangish. Alright, that's looking better. Let's just keep washing that off in the acid. Must have had some stuff on the wire here. Okay, I'm going to stick this in the copper solution. And let's see what we get. Oh yeah, there's the green. It was just a quick tinge, but let's try that again. I saw it really quick early on, and then it faded, then it came back for another flash, but let's see. There it is. Boy, that's quick. Oh, there it is now. So I don't know if that's showing up on camera, but it's definitely kind of a green color. Let's try it one more time. Yep. So I don't know if this is showing up on the camera, but there's definitely a green copper color there. Alright, well I just wanted to give this a try because like I said, I don't have much experience doing this. And okay, I went through all the calculations. I weighed up all the precipitates, dried them out, weighed them up, and basically if it's chalcopyrite, the formula is Cu or copper, Fe or iron with 2 sulfur atoms on there. And it comes out to be about 35% copper, about 30% iron, and about 35% sulfur. So it looks like we definitely have copper there. Pyrite doesn't have copper, it's just FeS, just iron sulfide. And the amount of sample that we started with was 0.19 grams. I won't go through all the calculations, but that's after we put that piece of quartz in there with the chalcopyrite on there and dissolved it a little bit off, took it out and weighed it again. And that's what we got. So anyways, since chalcopyrite has 1 atom of copper and 1 atom of iron, it should be about the equal weight. Actually, it's going to have a little bit more weight of copper because it has a slightly higher atomic weight than iron. But the ratio is about 1.14 to 1 weight of copper to iron. And I went through and I weighed the precipitates, and I took into account that I took half of the first solution that was dissolved in acid, so you know, that wasn't the full sample. And then when I got to the copper, I divided that in half. So I multiplied the weight that I got from the copper precipitate by 4, since I divided it in half twice, and from the iron once. And I took into account the percentages of iron in the iron hydroxide and the percent of copper in the copper sulfide. But anyways, I ended up getting a significant amount of copper in there, but it wasn't quite the 1-to-1 ratio. It was actually about 71% copper to as compared to the iron, so 0.7 to 1 ratio, which is pretty darn close. My analytical technique, and I didn't start this to be a quantitative analysis, but anyways, just a couple hundredths of a gram difference in my weight could make a huge difference in the numbers. So if I wanted to do this quantitatively, I would definitely want a much bigger sample. I want to be much more careful with my methods, and actually probably practice doing it, because I haven't done it. The only other discrepancy that I found too was that the weight of the iron and copper that I got from the precipitates was almost, it was more than what I would expect from the sample that I dissolved. So I'm not sure where that air is coming from. Like I said, it could be weighing air or something throughout the process. But in any case, we did see that there was quite a bit of copper compared to the iron, and so I could feel pretty safe to say that that's chalcopyrite, or at least a good portion of it is chalcopyrite or some sort of combination thereof. So, well, if you're still awake after seeing this whole video, congratulations. Thanks for watching. It was a lot of fun. I learned a lot about doing the analysis. I don't know that much about rocks and minerals or the appearances, so this chemical confirmation will be a great help for me to learn, and it was a lot of fun. I just like chemistry. I had a little chemistry lab when I was a kid. So anyways, thanks for watching, and here's who knows what we'll find at our next field trip. I really appreciate all the effort in organizing the field trip that I went on, where I got this sample, and many others too. So it was a lot of fun. The whole process was fun. It was a lot of fun getting the samples, and a lot of fun doing the analysis here. So thanks again. We'll catch you all later.